I know what we have covered in the last few videos sounds very technical, but trust me, this lesson will make things much simpler for you to visualize. Previously, we talked about stoichiometry and some stoichiometric calculations. This concept of stoichiometry is used very commonly in chemistry, often in some chemical reactions, particularly when one reactant is used in excess quantity, so much so that it exceeds the amount required for that particular reaction. Now, hold on right here. I know you must be wondering, why is that done? This is done to ensure that all the other expensive reactants are completely consumed and so that the reactions occur faster. For example, we know that when you are using large amounts of oxygen, it makes things burn more rapidly. When we use an excess of it, the other reactant will be consumed earlier, so the reaction will be completed quickly. Makes sense, doesn't it? This reactant, which is consumed earlier, is called a limiting reactant. Why is that so? Because once this reactant is consumed, the reaction completely stops and no more product will form. So, since it is limiting the reaction, it is known as a limiting reactant. Let me put forth a more scientific definition of limiting reactant, which says that a limiting reactant is a reactant that controls the amount of product formed in a chemical reaction due to its smaller amount. Let's understand this concept with a practical example. Suppose you have 30 kebabs and 5 pieces of bread having a total of 58 slices. Now, if you do the calculation, you will quickly find out that you can only prepare 29 sandwiches because each kebab would be using 2 slices, right? We are left with one extra kebab, which is the excess reactant, and the 58 slices are the limiting reactant because once all the 58 slices are consumed, we cannot proceed further in making more sandwiches. So, any reagent which is totally consumed and hence stopping the continuation of reaction is a limiting reactant. I hope it is clear now. Now, let's consider another example of a reaction between hydrogen and oxygen to form water. Right below here is an equation. 2H2 plus O2 give us 2H2O. This tells us that 2 moles of hydrogen, which would be 4 grams, is reacting with 1 mole of oxygen, which is 64 grams to produce 2 moles of water, which is 36 grams of water. Since hydrogen is present in a comparatively lesser quantity, which is 4 grams, only compared to the 32 grams of oxygen, hydrogen can be evidently labeled as the limiting reactant. Students, do you know how to identify a limiting reactant? Well, don't worry, it is pretty simple. There are 3 straightforward steps that you need to keep in mind to spot a limiting reactant. The first step is to calculate the number of moles from the given amount of reactant. The second step is to find out the number of moles of the product using the balanced equation, and the third and the final step is to identify the reactants that produce a lesser number of moles or amount of the products.